Hello everyone, this is Satish and welcome to my YouTube channel. In this video, we'll take a look into a simple driver circuit that controls the speed of a DC motor. We are going to build this by using the most famous IC of our time, namely the 555 timer. The applications of the 555 timer are just too many to go through in one video. This IC has been around since the 70s and is even used to this day in a multitude of electronic applications. The IC can be used to generate precise PWM pulses, build oscillators, generate timing circuits, and so on. In this tutorial, we'll learn a quick way to put a few components together to build a motor driver circuit. Let's get started. In the schematic, you can see that we are using a 12-volt power supply for this project. The 555 timer is wired up in a configuration where it produces PWM pulses at pin 6, which is the threshold pin. Through the resistor R1 100K potentiometer and diodes D2 and D3, we are able to control the charging and the discharging times of capacitor C1. For instance, the charging path is through R1, D2, the potentiometer, and C1. The discharging path is from C1, the pot, and diode D3. The cathode of diode D3 is in turn connected to pin 7 of the timer, which is its discharge pin. The sum total of the charging and discharging times is the period of the signal. If the potentiometer charging resistance is high between pins CCW and wiper, the discharging resistance correspondingly goes down, since only the remaining of the total 100K resistance is seen between pins CW and wiper. What does this wiring structure give us? Well, it gives us the ability to independently control the charging and discharging times of the capacitor, and hence the duty cycle of the generated PWM pulses from the 555 timer without changing the frequency. Thus, the potentiometer will serve as a simple knob to change the speed of the motor. If you wish to generate a different frequency in your project, try using different values of C1, say 1 microfarad or 5 microfarads, and test the output at pin 3. For the 555 IC, the connections are simple as shown. Pin 1 goes to ground, pin 2 is shorted to pin 6, pin 3 is the output, pin 4 is the reset pin and is pulled to the input supply voltage of 12 volts, pin 5 is connected to 10 nanofarad capacitor, pin 6 the threshold pin, pin 7 is taken from the cathode of D3 as explained before, and pin 8 is VCC, which is 12 volts again. I've used an N-channel MOSFET in a TO220 package for this demo. The output from pin 3 of the timer is connected to a resistive divider of 100 ohms and 1K as shown. The motor leads are connected to the drain and the 12 volt supply. As a freewheeling diode, I've used a 1N4007 as shown in the schematic. I've designed a simple PCB and soldered all the components as discussed. Now, let's give it a spin and see the output. I'm using a fan motor for this project since that's what was lying around me at this time. Per the scope, we can see that we are generating PWMs as designed, and we are able to control the speed of the DC motor. Hope you learned something from this video. Thanks for listening and see you soon.